Implementing a man-in-the-middle attack using address resolution protocol spoofing. Let's begin. Have you ever looked at a computer and wondered, I wonder what that computer does all day with that user in front of it? Well, one way of finding out is implementing some ARP spoofing to do a man-in-the-middle attack. Now, ARP is an acronym that stands for Address Resolution Protocol. And what basically happens is on IP networks, IP version 4, we have IP addresses. For example, this PC right here, maybe it's 10.0.0.2. That's its IP address. And the default gateway, the firewall in this case, maybe it's .1 on that network. And it has another IP address on the outside. Well, if this PC wants to forward traffic to its default gateway, which in this case is the firewall, it needs to know the Ethernet layer 2 address. And to find out, it uses ARP. It goes something like this. An ARP request goes out, says, hey, everybody, it's a broadcast. I'm looking for the person who owns 10.0.0.1. If that's you, please give me an ARP reply with your layer 2 address. And the firewall would respond, and now the layer 3 to layer 2 mapping is in the ARP cache of this PC. A similar function happens up here on the firewall if it needs to discover the layer 2 address of some other device on the network that it wants to talk to. So how exactly does an ARP spoofing attack work? We're going to lie about the layer 3 to layer 2 mapping. So for this discussion, let's say this guy is .1, that's the IP address, and this guy is .2. And let's also say that the MAC address is up here, 000011111111 for that interface on the firewall, and the PC's MAC address administratively configured as sound like Fonzie, okay. So let's say those are the addresses involved. And they both know it. They've done their own ARP resolution. They know how to reach each other. If we want to put this BackTrack machine as a man in the middle, all we have to do is lie to this guy and lie to this guy. And let's say that our MAC address is something like 0000 CC1E6783. All we need to do is have the BackTrack machine tell this firewall, hey, dear Mr. 10.0.0.1, the MAC address of 10.0.0.2 is this guy. So in his MAC address table, in his cache, it's going to say, okay, great, to reach 2.2, I'm going to use this layer 2 address. And now any traffic that the firewall is trying to forward to .2 is going to be forwarded at layer 2 by the switched network over to the BackTrack device. That's half of the problem. The other half is we also need to lie to this guy. So we'll go to the PC and we'll say, hey, with ARP packets, hey, this is 10.0.0.1 talking, here's my layer 2 address, and it is 0000CC1E6783. And so effectively, this PC will believe that its default gateway's MAC address is this, the attacker, and the default gateway will believe that the layer 2 address of the PC is also the attacker. And guess what? All the layer 2 frames are going to be forwarded through the BackTrack device. Now, as a courtesy, of course, we'd want to make sure we're forwarding those frames on to the final destination so that we don't cause a complete denial of service. And that could be another reason we do the ARP spoofing, is simply to cause a complete failure of the PC to reach this default gateway. But if we want to route the traffic, all we need to do is set forwarding to on, and we can route it. So a typical transaction with ARP spoofing involved would be the PC, if it wants to go out to Google, for example, the frame would be sent to the BackTrack's MAC address. The BackTrack, we would go ahead and forward it to the default gateway, and then the default gateway would route it out to Google. Packet comes back, and the return traffic is going to go back to BackTrack, and then we'll go ahead and forward it to the PC. You know, we don't want to stop service, perhaps, but we absolutely are doing a man in the middle by simply lying to both devices regarding the layer 2 address of the other devices on the network. The tools we're going to use to implement this, first we're going to use Nmap, because if we have a BackTrack system, we need to know what the devices are on the network. So we'll do a quick scan to find out what the other devices are on that network. Then we use ARP spoof. We're going to use it twice. We're going to use once against this target and once against this target to lie and tell both of them that the corresponding IP address of the other device is really the BackTrack layer 2 address, and they'll believe it. And then we're going to use DriftNet, which is fantastic in URL snarf. DriftNet, oh my gosh, it's going to open up a separate window, and any traffic that we eavesdrop upon is going to be automatically be placed in that window, any graphics. So if you're curious about the graphics on the websites that people are going to, they'll pop right up on the BackTrack system. And URL snarf gives us all the nitty-gritty details of exactly the URLs they're going to and the versions of web software that are used on that device. It's fascinating, and we'll take a look at both of those. The main reason they're bringing these two right here is because I want to just demonstrate some additional functionality. I mean, even without these, we could just put on Wireshark eavesdrop and see all the traffic as far as what's going on between the client and the external resources that he's accessing. So let's start by introducing the players here. This is a Windows XP machine that's currently sitting on the 10 network, and let's just verify its IP address with an IP config, and that looks good. It's at 10.0.0.2, which is great. If we do a ARP-A, it currently knows about 10.0.0.1, which is its default gateway, which is the firewall. And if we do an IP config /all right here, we can also verify the layer 2 address that we're currently using on this system. So there's the layer 2 address right there. I administratively configured that just to be really easy to recognize. Next, let's take a look at the firewall as well. Let's do a show ARP. This happens to be an adaptive security appliance, and it's showing here that it knows about a couple of MAC addresses, 2 on the inside, 2 on the outside, but it does definitely know about the Windows PC at 10.0.0.2 and its layer 2 address, which is 0000 AAAA. This 10.0.0.4, by the way, that's our BackTrack system, which is about to do an ARP poisoning attack against the firewall and against the PC at 10.0.0.2. So if we're on this network and we're not sure about exactly which devices are there, we can use a previous tool like Nmap just to verify who's there. So Nmap-F, that's going to search the top 100 ports, and let's search that whole range, the whole 10 network. And it found everybody. So I don't have that many devices there, but it didn't take that long either way. So it found 10.0.0.1, which is my ASA firewall, and it says, oh, he's got 443 open for management purposes. And then it also found 10.0.0.2, which is our Windows XP machine. It also found 10.0.0.4, which is our BackTrack system. And it also found 10.0.0.55. So 10.0.0.5, it's got the X11 service running. That's for the Xming. That happens to be my host computer that I also have placed on this network. So the two that we're going to focus on are these guys, the default gateway and the actual IP address of the little XP box that's going out to the internet. One other thing to do before we actually do the ARP spoofing is let's just make sure we have basic connectivity to the internet to begin with. So we'll open up a browser and let's see what's in our history. Google. All right, so let's go to google.com. Just wanted to make sure that we have functionality before we start implementing the attacks, and it looks like we do. On the BackTrack system, we've already done this previously in a previous nugget, but in case you didn't do that lab and you're just doing this fresh, I want to make sure we're doing forwarding, because if we're doing a man-in-the-middle attack and somebody sends us a frame, if we're not enabling routing on our BackTrack system, we're not going to be willing to forward it out that same interface and onto its true default gateway so it can be routed the rest of the way. So we want to make sure we have a 1 set there. So even if it was already a 1, if you echo a 1 to that file again, it's not going to hurt anything. If we wanted to verify, which is not a bad idea, to make sure that the command we thought was working does, let's go ahead and just do a more of that file and just verify that we have a 1 there. So we are basically now willing to route IP packets for other people. The first half of the ARP spoofing, we're going to aim right at 10.0.0.2. We're basically going to say, hey, guess what? If you're looking for the layer 2 address of 10.0.0.1, it's my address, says the BackTrack system. This is now saying, hey, guess what? The MAC address for 10.0.0.1 is, and it lists the BackTrack system's MAC address, the one that ends in 6783. And then I just let that run. We're just going to poison the ARP caches, lying over and over and over again. And just going to leave that running in one window. Let's go to a second window because we also need to lie to the firewall itself. And to do that, we're going to say ARP spoof-I, specifying the interface that we want to use, which in our case is Ethernet 0. We're going to say, okay, dear Mr. 10.0.0.1, you are the victim. And what we're going to do is anytime you need to reach 10.0.0.2, whatever MAC address you had for 10.0.0.2, it's not true. It's really our MAC address. And again, we're lying one more time, specifying that it's the MAC address ending in 6783. So if we leave both of those running, which I'm going to, by the way, let's go ahead and take a look at the ASA. And just a moment ago, or a few minutes ago, this was the ARP cache. This is the accurate ARP cache, by the way, where this device, the firewall, believes to reach 10.0.0.2, it can reach it at the layer 2 address with all the A's in it. Well, now that we've poisoned the ARP cache of the firewall for that entry, if we simply use an up arrow key and bring that up again, check this out. It now says, oh, to reach 10.0.0.2, the MAC address I should use is the BackTrack system. And it will use it. At layer 2, it just forwards it, encapsulates the frame, sends it, and it sends it right to our BackTrack system. And we also could look at the PC. Let's go ahead and do that real quick. So on our PC, when we did the ARP-A, it said, okay, to reach 10.0.0.1, the MAC address is this. So in the ARP cache of the PC, it says, okay, to reach 10.0.0.1, what I used to know, or what I believed anyway, was the address of 00ABCD. This is also administratively configured. This is the MAC address that I would use to reach my default gateway of 10.0.0.1. But now that we're running the ARP poisoning attack against it as well, check this out. We'll go ahead and hit the up arrow key a couple times, and now it says, oh, to reach 10.0.0.1, I know how to get there. And that's the BackTrack machine's MAC address. So effectively, we're doing ARP spoofing against the default gateway regarding the PC at 10.0.0.2, and we're doing ARP spoofing against the PC regarding its ARP entry of its default gateway at 10.0.0.1. We're effectively now a man in the middle. So now that we've got the man in the middle attack working, or we think it's working, let's verify it. Let's go ahead up and open up a couple windows inside of BackTrack. The first one we'll do driftnet-I. Again, to get context-sensitive help with any of these commands, it's driftnet space -H, and it'll give you the syntax. The -I represents we're going to listen to and pay attention to the traffic we see on Ethernet 0, and that's going to open up a separate window. Let me show you. And this separate window right here is where the graphics are going to pop in. So that customer that we're doing the man in the middle against, as he goes out and visits sites, any graphic images are going to be popped into this one. Now, does that mean every single graphic image? The answer is no. If he's going up through SSL or some other encrypted technology to a website, of course we can't see the encrypted data, but any plain text images certainly will pop in right there. The other tool we're going to launch is URL snarf right here. And URL snarf is simply going to give us the details on all the URLs that customer happens to be going to. So we'll launch that one as well. So with both of those running, and let me make this window a little bit bigger to make it a little bit more fun, let's bring in our victim. So here's our little Windows XP box, and let's open up a browser. So we'll open up a browser, and let's just go out to www.google.com. So as we go out to google.com, this window up here is taking a look at all the details, and over here we have the graphical images that are being pulled down. So if we search for example, I think my name is pretty safe, Keith Barker, CCIE, press enter. The images that come in, yeah, that's mostly me. So yeah, in fact, these four are me, and they're somewhere on the pages that got pulled down. If we went to images and did that same kind of search, we would get even more. So most of these people are me, and there's a few that aren't me, but there you have it. And that's the graphical images that are being pulled down from that customer on this PC right here and showing up on our BackTrack system in a separate window. One other really cool thing we could do is Wireshark. I mean, Wireshark would allow us to see not only the URLs being visited and the graphics that are being pulled down, but also we could see every ounce of every packet that's going between the client and the internet. In fact, we should do that too since we're right here. So we'll simply bring up a command line, and we'll simply type in Wireshark. And that'll bring up Wireshark. And on Wireshark, we'll say we want to go ahead and we want to make this window bigger, first of all. And we want to listen on Ethernet 0. Please start. It'll start capturing traffic. We'll go back to our client here. And on this client page, we'll go out to www.cisco.com, for example, or something else. And then we'll go ahead and stop that because it's going to rotate pages periodically. And here's all the traffic. So if we go back here and stop the madness, because there's a lot of traffic, and that was quite a bit of traffic. We got over close to 3,000 packets in those few seconds right there. So yet another way to take a closer look on exactly the data that's involved. And if the client had logged in through HTTP or done other clear text applications like FTP where they used a username or a password, we would be able to capture every ounce of that, and those passwords would then be known to us. Now, if we're done with the attack, we really don't want all that traffic coursing through our BackTrack. So when we're done, we can just do a Control-C, and I want you to take a look at the very bottom of the screen right here. What it's going to do, it's going to repopulate with the correct ARP entries right here. It's like restoring it back to normal before we did the attack, and we'll go do it on the other system as well. So the Control-C takes a few seconds, and it repopulates the correct information. And that's the ARP entries that should be in place before we started doing the man in the middle and the ARP spoofing. In this video, we've identified how we can implement an ARP spoofing attack using this primary tool of ARP spoof. The driftnet and the URL snarf and Wireshark are just great ways of seeing that content and what's going on, but the actual tool to implement it was ARP spoof. We also used Nmap to identify the devices on a network so we could go ahead and implement the man-in-the-middle attack. I also want to point out that there's some routers out there. Let's say that we had, instead of doing a firewall, let's say it's a router. Let's say it's R1, and its address is 10.0.0.1. Some routers, not all, but some routers, when they see that there's ARP spoofing happening, and how would they know that? Well, for example, it knows its MAC address. It knows that its IP address is 10.0.0.1. If it sees messages that are telling the network, the rest of the network, hey, my IP address is 10.0.0.1 and my layer 2 address is wrong, we'll just say anything other than his real layer 2 address, what some routers will do is they will do a gratuitous ARP, which is basically an ARP that wasn't asked for, and they'll advertise out saying, hey, my IP address is 10.0.0.1 and here's my real MAC address. And that's a great defense mechanism. So if you're on a network and the router does behave that way, that's fantastic. But unfortunately, not every router does behave that way. So as you set up your test labs and set up your man-in-the-middle with ARP spoofing, you might want to just pay attention to the behavior of the router. Most corporate routers, for example, Juniper, Hewlett-Packard, Cisco, they've got debug type of techniques where you can actually ask the router to tell you about ARP messages that are happening. And then you can actually take a closer look to see the actual behavior of the router that's in your test network. I have had a lot of fun in this nugget. I'm really glad that you joined me. I hope this has been informative for you, and I'd like to thank you for viewing.